I've spent my life looking at the heavens, trying to decipher the stories written in the language of light and gravity. I've seen things that have filled me with wonder, things that have challenged my understanding of the cosmos. But nothing has prepared me for 3I Atlas. It's an object that defies easy categorization, a celestial enigma that forces us to question our most fundamental assumptions about what can and cannot exist in the vast emptiness between the stars. When we first detected it, we thought it was just another interstellar visitor, a comet like 2I Borisov, a wanderer from another star system passing through our own. We were excited, of course. Any chance to study a piece of another solar system is a gift. But as we gathered more data, a different picture began to emerge. A picture that was far more complex and far more puzzling than we could have ever imagined. The heat signature, the way it reflects sunlight, the way it moves, none of it quite fits. It's like finding a footprint in the sand that doesn't belong to any known animal. You know something has been there, but you don't know what it is. And that not knowing, that's the feeling that has consumed me and many of my colleagues for months now. We are confronted with a mystery, a grand cosmic puzzle, and the pieces just aren't fitting together. The story of 3I Atlas is the story of that puzzle, a story of scientific discovery at its most thrilling and most frustrating. It's a story that is still unfolding, a story that could change everything we think we know about our place in the universe. My journey with 3I Atlas began, as so many astronomical discoveries do, with a faint pinprick of light in a sea of darkness. The Atlas Survey, the Asteroid Terrestrial Impact Last Alert System, is our planetary defense system, a network of telescopes that scans the sky every night, looking for anything that moves. Its primary mission is to find asteroids that might pose a threat to Earth, but in doing so, it sometimes stumbles upon other, more exotic objects. And on the 1st of July 2025, it found something truly extraordinary. A faint object, moving on a trajectory that was not bound to our sun. A hyperbolic trajectory. That's the telltale sign of an interstellar visitor. It was moving too fast to be captured by the sun's gravity. It was just passing through. We designated it 3I Atlas, the third interstellar object ever detected. The I for interstellar. The 3 because it was the third of its kind. The first was Oumuamua, that strange, cigar-shaped object that tumbled through our solar system in 2017. The second was 2I Borisov, a much more familiar-looking comet, discovered in 2019. And now, we had a third. The initial observations were consistent with a comet. It had a coma, a fuzzy envelope of gas and dust, and a tail. We pointed our telescopes at it, eager to learn more. We used the James Webb Space Telescope, the Hubble Space Telescope, the Atacama Large Millimeter Submillimeter Array, ALMA, in Chile. We threw everything we had at it, and the more we looked, the stranger it got. The first hint that something was amiss came from its thermal properties. Comets are essentially dirty snowballs, mixtures of ice, rock, and dust. As they approach the sun, the ice sublimates, turning directly from a solid to a gas. This outgassing creates the coma and tail. The amount of outgassing is directly related to the temperature of the comet's nucleus. We have models, sophisticated computer simulations, that predict how a comet should heat up as it gets closer to the sun. These models are based on decades of observations of comets in our own solar system. They're very good. They work, but they didn't work for 3I Atlas. The object was producing a coma. It was outgassing. But the amount of outgassing didn't match the temperature we were measuring. It was as if the comet was producing more gas and dust than it should have been for its temperature. Or, to put it another way, its heat pattern didn't match that of a normal comet. It was too hot in some places, too cold in others. It was patchy. We saw distinct thermal regions on the surface, areas of intense heat, right next to areas of extreme cold. This is not what we expect to see on a simple, inert body being heated by the sun. The sun's radiation should heat the surface uniformly. There should be a smooth temperature gradient from the sun-facing side to the dark side. But that's not what we saw. We saw a mosaic of hot and cold spots, a thermal landscape that was far more complex than anything we had ever seen on a comet before. One of the most striking features of this thermal anomaly was the presence of what appeared to be concentric thermal rings. Imagine dropping a pebble into a pond and watching the ripples spread out. Now imagine those ripples are made of heat, and they are frozen in place on the surface of a comet. That's what it looked like. We saw a series of nested rings, each with a different temperature. The center was hot, then a cooler ring, then a hotter ring, and so on. This is simply not a pattern that can be explained by solar heating alone. The sun's energy arrives in parallel rays. It can't create concentric rings of heat. So, what could? We considered a number of possibilities. Could it be due to the composition of the nucleus? Perhaps there are patches of highly reflective ice next to patches of dark, heat-absorbing dust. This could create some temperature variations, but it's hard to see how it could create such a regular, ring-like pattern. We also considered the possibility of cryovolcanism, or ice volcanoes. This is a phenomenon we've seen on some of the icy moons of Jupiter and Saturn. Pockets of liquid water or other volatiles beneath the surface can erupt, spewing plumes of gas and ice into space. This could certainly create localized hotspots. But again, it's difficult to explain the concentric ring pattern. An eruption would create a single hotspot, not a series of them. And the energy required to power such eruptions on a small body like a comet is immense. It's not impossible, but it's a stretch. Then there was the non-gravitational acceleration. This is another key piece of the puzzle. As a comet outgasses, the escaping gas acts like a tiny rocket engine, pushing the comet slightly off its purely gravitational path. This is a well-understood phenomenon. We see it in comets all the time. The amount of non-gravitational acceleration is directly proportional to the amount of outgassing. More outgassing, more acceleration. But with 3I Atlas, the numbers didn't add up. We measured a significant non-gravitational acceleration, a deviation from its expected trajectory that could only be explained by a force other than gravity. But the amount of outgassing we observed was not enough to account for it. Not even close. The comet was moving as if it was being pushed by a much larger force than the one we could see. It was as if there was a hidden engine, a source of thrust that was invisible to our instruments. This is a profound mystery. It's a direct violation of our understanding of cometary physics. We have two measurements, the amount of outgassing and the non-gravitational acceleration. In a normal comet, these two measurements are consistent with each other. In 3I Atlas, they are not. There is a discrepancy, a mismatch, and we don't know why. This discrepancy is what has led to some of the more speculative theories about 3I Atlas. When you have a phenomenon that you can't explain with known physics, you have to start thinking outside the box. And some of the ideas that have been proposed are truly mind-bending. One possibility is that the outgassing is not uniform. Perhaps the gas is being ejected in a highly collimated jet, a narrow beam of high-velocity particles. This would be much more efficient at producing thrust than a diffuse cloud of gas. It would be like the difference between a fire hose and a sprinkler. A fire hose can knock you off your feet. A sprinkler will just get you wet. If 3I Atlas is ejecting a jet of gas, it could explain the non-gravitational acceleration, but it raises another question. What is creating the jet? A normal comet doesn't do that. The outgassing is more or less uniform in all directions. To create a jet, you need some kind of nozzle, some kind of structure that can focus the flow of gas. And that's where things start to get really strange. Because that sounds a lot like technology. It sounds like a rocket engine. I want to be very clear here. I am not saying that 3I Atlas is an alien spaceship. I am a scientist. I deal in evidence and data, and the evidence is not there to support such an extraordinary claim. But I am also a scientist who is confronted with a set of observations that cannot be explained by our current understanding of the natural world. And in that situation, I have to be open to all possibilities, no matter how outlandish they may seem. The history of science is filled with examples of discoveries that were initially met with disbelief and ridicule, only to be later proven true. The idea that the Earth revolves around the Sun was once considered heresy. The idea that continents drift across the surface of the planet was once dismissed as a fantasy. The idea that the universe is expanding was once thought to be absurd. So, when we are faced with a true anomaly, a genuine mystery, we have to be careful not to let our preconceived notions blind us to the truth. We have to follow the evidence, wherever it leads. And right now, the evidence is leading us down a very strange path. Let's go back to the heat pattern. Those concentric rings, I've been thinking a lot about those rings. What could create such a pattern? One idea that has been bouncing around in my head is the possibility of some kind of internal energy source. What if 3I Atlas is not just a passive piece of rock and ice being heated by the sun? What if it's generating its own heat? This is not as crazy as it sounds. We know that radioactive decay can generate heat. It's what keeps the Earth's core molten. But the amount of radioactive material you would need to create the kind of heat we're seeing on 3IATLAS is enormous. It would have to be made of almost pure uranium. And that's just not plausible. So, if it's not radioactive decay, what could it be? This is where we enter the realm of pure speculation, but it's a fun place to be. As a scientist, it's where the new ideas come from. What if there is some kind of novel physical process at work? Something we haven't discovered yet? A new form of energy? A new type of matter? It's a tantalizing thought. The universe is a big place. It's been around for 13.8 billion years. Is it really so arrogant to think that we, on our tiny little planet, have figured it all out? I don't think so. I think it's far more likely that we are just scratching the surface of what there is to know. And 3I Atlas, this strange visitor from another star, could be our first glimpse of that deeper reality. It could be a messenger, a harbinger of a new physics, or it could be something else entirely. It could be a piece of alien technology, a probe sent out by another civilization to explore the galaxy, a derelict ship drifting through the interstellar void for millions of years, a cosmic buoy marking a path to another world. I know how this sounds. It sounds like science fiction. But is it any more of a stretch than the idea of a comet that generates its own heat in concentric rings? Or a comet that moves as if it has an invisible engine? I don't know. And that's the honest answer. I don't know what 3I Atlas is. And neither does anyone else. We are all just staring at the data, trying to make sense of it. And the data is telling us a story that we don't understand. Not yet. But we are working on it. We are building new models, new simulations. We are trying to come up with a natural explanation for what we are seeing. We are exploring every possibility, no matter how unlikely. We are looking for a way to make the pieces of the puzzle fit together. And we will keep looking, because that's what we do. We are explorers. We are detectives. We are scientists. And this is the greatest mystery of our time. The mystery of 3I Atlas. A mystery that has the potential to change everything. A mystery that has already changed me. It has reminded me of why I became a scientist in the first place. To explore the unknown. To push the boundaries of human knowledge. To look up at the night sky and wonder. And to never, ever stop asking questions. Because the universe is full of wonders. And 3I Atlas is just the latest one. A strange, beautiful, and utterly baffling wonder. A visitor from another star that has come to our solar system to teach us a lesson. A lesson in humility. A lesson in the power of the unknown. A lesson that we are only just beginning to learn. Let me delve deeper into the specifics of the thermal anomaly, because it is here that the mystery of 3I Atlas truly begins to unfold. When we talk about the heat pattern of a comet, we are essentially talking about how its surface temperature varies as it is illuminated by the sun. For a simple, inert body, this is a straightforward calculation. The amount of energy absorbed depends on the albedo, or reflectivity, of the surface. A dark surface absorbs more energy and gets hotter. A bright surface reflects more energy and stays cooler. The absorbed energy is then radiated back into space as thermal infrared radiation. The temperature of the surface is determined by the balance between these two processes, absorption of solar energy and emission of thermal energy. We can model this with a great deal of precision. We can predict the temperature of any point on the surface of a comet at any given time. And for most comets, our models work beautifully. The predicted temperatures match the observed temperatures. But not for 3I Atlas. For 3I Atlas, the observed temperatures were all over the place. We saw regions that were much hotter than our models predicted, and regions that were much cooler. And the distribution of these hot and cold regions was not random. It was structured. It was organized. It was, for lack of a better word, patterned. The concentric ring pattern is the most striking example of this. We used ALMA, the Atacama Large Millimeter Submillimeter Array, to map the thermal emission from the nucleus of 3I Atlas. ALMA is an incredible instrument. It's a collection of 66 radio telescopes in the high desert of Chile, working together as a single, giant telescope. It can see the faint thermal glow of cold dust and gas with unprecedented resolution, and what it showed us was breathtaking. A series of concentric rings of thermal emission centered on a single point on the surface of the nucleus. The central region was the hottest, with a temperature of around 200 Kelvin, or -73 degrees Celsius. This was surrounded by a cooler ring, with a temperature of around 150 Kelvin, then another hot ring, then another cool ring. The pattern was so regular, so perfect, that it looked artificial. It looked like a target. It looked like something that had been designed. My first reaction when I saw the image was disbelief. I thought it had to be an artifact of the data processing. I've seen plenty of strange things in my career, but I had never seen anything like this. We checked and rechecked our data. We ran every diagnostic we could think of, but the pattern was real. It was there in the data. It was a genuine feature of 3I Atlas. So, what could cause such a pattern? As I mentioned before, it's very difficult to explain with solar heating alone. The sun's energy is a plane wave. It can't create concentric circles. We considered the possibility of a spinning, precessing nucleus. If the comet is tumbling in a complex way, then different parts of the surface would be exposed to the sun at different times. This could create some interesting temperature patterns, but it's hard to see how it could create such a regular, concentric pattern. The pattern would be much more chaotic, much more irregular. We also considered the possibility of subsurface heat sources. Perhaps there are pockets of radioactive material beneath the surface, arranged in a circular pattern. But this seems incredibly contrived. Why would radioactive material be arranged in such a specific way? It makes no sense from a geological perspective. We are left with a profound puzzle, a thermal pattern that seems to defy any natural explanation. It's a clue, a very important clue, but we don't know what it means yet. And the concentric rings are not the only thermal anomaly we've observed. We've also seen evidence of rapid temperature fluctuations. The temperature of certain regions on the surface seems to be changing on very short timescales, much faster than can be explained by changes in solar illumination. It's as if there are switches being flipped, turning the heat on and off. This is another observation that is very difficult to explain with our current models. It suggests that there is some kind of active process at work, something that is modulating the flow of heat on the surface of the comet. What could this process be? We don't know, but it's another piece of the puzzle, another clue that points to something very strange happening on 3I Atlas. Now, let's talk about the non-gravitational acceleration in more detail. This is, in many ways, an even more profound mystery than the thermal anomalies. The non-gravitational acceleration is a direct measurement of the forces acting on the comet. Other than gravity, it's a very precise measurement. We can track the position of the comet with incredible accuracy using a network of telescopes around the world. We can predict its trajectory based on the gravitational pull of the sun and the planets. And if the comet deviates from that predicted trajectory, we know that there must be another force at work. For a normal comet, that force is outgassing. The sublimation of ice from the nucleus creates a jet of gas that pushes the comet. The strength of that push is proportional to the amount of gas being produced. We can measure the amount of gas being produced by observing the brightness of the coma. And for a normal comet, the two measurements agree. The observed non-gravitational acceleration is consistent with the observed outgassing rate, but for 3I Atlas, they don't agree. The observed non-gravitational acceleration is much larger than what can be explained by the observed outgassing rate. The comet is being pushed with a force that is at least an order of magnitude greater than the force we can account for. This is a stunning result. It's a direct challenge to our understanding of cometary physics. It's as if we are watching a sailboat moving across a lake on a windless day. We can see the sails, but there is no wind. And yet, the boat is moving. We would be forced to conclude that there is a hidden engine. And that's the situation we are in with 3I Atlas. We can see the outgassing, the sails of the comet, but the wind is not strong enough to explain its motion. There must be a hidden engine, a source of thrust that is invisible to us. What could this hidden engine be? One possibility, as I mentioned before, is a highly collimated jet. If the outgassing is not a diffuse cloud, but a narrow, high-velocity beam, then it would be much more efficient at producing thrust. But this just pushes the question back a step. What is creating the jet? A normal comet doesn't have a nozzle, it doesn't have a rocket engine. So, if 3I Atlas has one, where did it come from? Is it a natural formation? It's hard to imagine how. A nozzle is a very specific, engineered shape. It's not something that you would expect to find on a random chunk of rock and ice. This is one of the reasons why the idea of an artificial origin for 3I Atlas is so compelling to some. A collimated jet is a hallmark of technology. It's what we use to propel our own spacecraft. So, if we see it on an interstellar object, we have to at least consider the possibility that it is not natural. Another possibility is that the outgassing is not composed of the typical volatiles we see in comets, like water and carbon dioxide. Perhaps it is composed of something much lighter, like hydrogen. Hydrogen is the most abundant element in the universe, but it is very difficult to detect. It doesn't radiate in the visible or infrared parts of the spectrum. So, it's possible that 3I Atlas is ejecting a large amount of hydrogen gas, and we just can't see it. This would explain the non-gravitational acceleration, but it raises another question. Where is the hydrogen coming from? A comet is not a star. It doesn't have a fusion reactor in its core, so it can't be producing hydrogen. It would have to be carrying it, and a comet is not a very good container for hydrogen. Hydrogen is a very light gas. It would escape very easily. So, for a comet to be carrying a large amount of hydrogen, it would have to have a very unusual structure. It would have to be some kind of celestial thermos bottle. A natural formation? Again, it's hard to imagine how. It sounds more like a fuel tank. And then there is the most speculative possibility of all. The possibility that the non-gravitational acceleration is not due to outgassing at all. The possibility that it is due to some other force, a force that we are not familiar with, a force that is not part of the standard model of physics. This is the most exciting possibility and also the most unlikely, but we can't rule it out. The history of science is a history of discovering new forces. We discovered gravity. We discovered electromagnetism. We discovered the strong and weak nuclear forces. Is it so crazy to think that there might be a fifth force? A force that only interacts with interstellar objects? A force that we have never seen before because we have never had the chance to study an object like 3I Atlas up close? I don't know, but it's a thought that sends a shiver down my spine. The thought that we might be on the verge of a new scientific revolution. A revolution that could be triggered by this strange visitor from another star. So, we have the thermal anomalies, the concentric rings of heat, the rapid temperature fluctuations, and we have the non-gravitational acceleration, the invisible engine. These are the core mysteries of 3I Atlas. These are the observations that defy our understanding of the natural world, and these are the observations that have led to the intense debate and speculation that surrounds this object. Is it a natural object? Is it an artificial object? We don't know. And anyone who tells you that they do know is not being honest. We are in a state of profound uncertainty, and that's a good thing. It's in these moments of uncertainty that science makes its greatest leaps forward. It's when we are forced to confront the limits of our knowledge that we are able to push those limits back. And 3I Atlas is pushing us. It's pushing us to be better scientists, to be more creative, to be more open-minded, to be more willing to challenge our own assumptions. It's a gift, a strange, baffling, and ultimately beautiful gift from the cosmos. A gift that we are still unwrapping. A gift that may hold the key to understanding our place in the universe. A gift that has already changed the way I look at the night sky. I no longer see just stars and planets and galaxies. I see a universe of infinite possibilities. A universe where anything can happen. A universe that is far stranger and more wonderful than we could have ever imagined. And I can't wait to see what other surprises it has in store for us. The journey with 3I Atlas is just beginning. And I have a feeling that it's going to be a wild ride. The deeper I go into the data on 3I Atlas, the more I realize that the term heat pattern is a gross simplification for what we are actually observing. It's not just a pattern. It's a thermal architecture, a complex, dynamic system that seems to be actively managing its energy budget in a way that is utterly foreign to any natural comet I have ever studied. Let's return to the concept of thermal inertia. In a typical comet, the surface layer, the regolith, acts as an insulator. When the sun hits it, the surface temperature rises quickly, but the heat takes time to penetrate to the interior. This time lag is the thermal inertia. It's a measurable property, and it's what dictates the timing and location of outgassing. For a comet with low thermal inertia, the outgassing starts almost immediately after the sun hits a spot. For a comet with high thermal inertia, the outgassing is delayed, often happening on the night side or after the comet has passed its closest point to the sun. This is all standard cometary physics. We have models that incorporate this, and they are highly accurate for solar system comets. But 3I Atlas throws a wrench into this entire framework. Our initial thermal models, which assumed a typical cometary composition and thermal inertia, predicted a certain temperature profile and a corresponding outgassing curve. The observations, however, showed a massive mismatch. The onset of water activity, for instance, was observed much closer to the sun than our models predicted for a typical comet. This suggested that the surface was heating up much faster than expected, implying a very low thermal inertia. It was as if the surface was made of a material that was a near-perfect conductor of heat, or that the insulating layer was incredibly thin or non-existent. However, this low thermal inertia model immediately clashed with other observations. If the thermal inertia was so low, the surface temperature should drop just as quickly when the comet rotates away from the sun. But we observed regions that maintained a surprisingly high temperature even on the night side. This suggests a high thermal inertia, or, more radically, an internal heat source that is not dependent on solar illumination. We are faced with a paradox. The comet seems to exhibit both extremely low and extremely high thermal inertia, depending on which part of the observation you focus on. It's a contradiction that cannot be resolved within the standard cometary paradigm. This is where the idea of an adaptive thermal architecture comes into play. It's a concept that is almost science fiction, but it's the only one that seems to reconcile the contradictory data. What if the surface material of 3I Atlas is not static? What if it is a kind of metamaterial that can actively change its thermal properties? Imagine a surface that, when exposed to intense solar radiation, instantly becomes highly conductive to shed the heat and trigger outgassing earlier than expected. And then, when it rotates into the shadow, it instantly becomes a near-perfect insulator to retain the heat or perhaps to manage the internal energy release. This would explain the early onset of activity and the persistent night-side warmth. It would explain the thermal mismatch. It would explain the pattern. The concentric thermal rings I mentioned earlier, those distinct, nested bands of hot and cold, could be the visible manifestation of this active thermal management system. They could be zones where the material is cycling between high and low conductivity states, perhaps in response to internal energy pulses or structural requirements. The regularity of the pattern is the most compelling piece of evidence for a non-natural origin. In nature, we expect randomness, irregularity, and fractal complexity. We do not expect perfect circles centered on a single point. That is the signature of design, of engineering. Furthermore, a smaller nucleus would be more susceptible to tidal forces and fragmentation, which we have not observed. So, while possible, it doesn't fully resolve the issue. The second possibility, a much higher gas velocity, is intriguing. The thermal speed of water vapor at cometary temperatures is typically a few hundred meters per second. To get the observed acceleration from the measured mass loss rate, the gas would have to be ejected at speeds far exceeding this, perhaps in the range of kilometers per second. This would require a mechanism to collimate and accelerate the gas, a process that is not seen in natural cometary outgassing. This brings us back to the idea of a nozzle or a propulsion system. A natural comet's outgassing is a relatively slow, diffuse process. A highly accelerated jet is a signature of engineering. The third possibility, that the force is not outgassing, is the most radical. If it's not outgassing, what is it? It could be radiation pressure acting on a very large, very thin object, like a solar sail. This is the hypothesis that was put forward for 1I Oumuamua, and it is equally applicable here. If 3I Atlas is a large, flat, thin object, its area-to-mass ratio would be enormous. The pressure of sunlight alone could account for the non-gravitational acceleration without any need for outgassing. This would also explain the lack of a massive gas cloud, which is a key prediction of the outgassing model. If the acceleration is due to a solar sail, then the thermal anomaly takes on a new meaning. The heat pattern might not be a result of heating, but a result of active cooling or thermal signature management on the surface of a technological artifact. The concentric rings could be radiators, designed to dissipate waste heat from an internal system or to maintain the structural integrity of a thin, fragile shell. The most recent data, which I have been poring over, suggests another layer of complexity: the compositional anomaly. The Webb telescope has given us an unprecedented look at the chemical makeup of the gas and dust being ejected by 3I Atlas. We've confirmed the presence of typical cometary volatiles like water, carbon dioxide, and carbon monoxide. But we've also detected unusual amounts of certain heavy elements, including nickel and iron, in the coma. These are not typically seen in the gas phase of cometary outgassing. They are usually locked up in the dust grains. To see them in the gas phase suggests that the temperature of the outgassing region is much higher than expected, or that the material itself is being ejected in a way that is not purely thermal sublimation. It suggests a high-energy process is at work, something that can vaporize refractory materials like metals. This high-energy process could be the key to the heat pattern. If there is an internal power source, perhaps a small fission or fusion reactor, or some other exotic energy generator, it would produce a tremendous amount of heat. This heat would then have to be managed and dissipated. The concentric thermal rings could be the external heat exchangers of this internal power source. The rapid temperature fluctuations could be the system actively regulating its power output. The high-velocity jets could be the exhaust from this engine, a combination of sublimated ice and vaporized metals, providing the non-gravitational thrust. The sheer scale of the problem is what makes it so fascinating. We are trying to explain a macroscopic object, millions of kilometers away, with a set of observations that are fundamentally contradictory. We have a thermal signature that suggests both high and low thermal inertia. We have a non-gravitational acceleration that is too large for the observed outgassing. We have a chemical composition that suggests a high-energy process. And we have a geometric pattern, the concentric rings, that suggests design. I've spent countless hours running simulations, trying to find a natural configuration that could produce these effects. I've modeled comets with highly porous fractal structures. I've modeled comets with internal pockets of highly volatile super ices. I've modeled comets with highly anisotropic outgassing. And in every single case, the model fails to reproduce the full suite of observations. You can explain one anomaly, but not all of them. You can explain the non-gravitational acceleration with a small, dense nucleus, but then you can't explain the massive coma. You can explain the early water activity with low thermal inertia, but then you can't explain the night-side warmth. The only way to make the data fit is to introduce a level of active control and structural complexity that is simply not found in any natural celestial body. This is the point where I, as a scientist, have to step back and consider the implications. If the object is not natural, then it is artificial. And if it is artificial, then it is a product of intelligence. This is not a conclusion I reach lightly. It is a conclusion that is forced upon me by the data. The data is screaming at us that this object is not a comet. It is something else. Something that is actively managing its thermal signature, its trajectory, and its composition. Something that is, in a word, engineered. The implications of this are staggering. If 3I Atlas is a technological artifact, it means that there is a civilization out there that is capable of interstellar travel, capable of building objects that can survive the harsh environment of the interstellar medium for millions of years, and capable of designing a thermal architecture that is beyond our current understanding of physics. It means that we are not alone. And that is a realization that changes everything. It changes our place in the universe. It changes our understanding of life. It changes our future. I continue to work on the problem, of course,